Okay, so I just want to give a quick, for those people who don't know me, my name is Robin Getz. I'm an engineer in analog devices. We just want to give a quick chat about using open source hardware for lab equipment. You know, there's been a lot of discussion about open source hardware and you know, making sure that it can do what you want. We're a big proponent of that. We want to make sure that that we do that, and not only do we make open hardware available for people, but also we use it internally as well. So I showed in my sponsor talk a few boards that ADI makes that are like Arduino shields and these kinds of things. And they're like RF detectors and power detectors that you can use. Oh, here we go. Thanks so much, Derek Spinoff. And you know, these you can totally use for, you know, lab equipment. These are actually, the devices themselves are actually calibrated in dBm, so you can use those. A couple of the other things we've done is we've done some power supplies. So this is a 0 to 20 volt power supply, 0 to 3 amps, that is actually controlled with a Raspberry Pi Zero, so you can play Minecraft on it too, when people aren't watching you. One of the devices that ADI just released is this AD9166, which is a high-speed, like 12 gigasample per second converter. It has a GSD interface on it. So it's a 15 gigabit per second kind of converter. But this is not really what you might think of as a lab kind of device. So what we did is we ignored the GSD interface, because built into it, it actually has a giant NCO, a numerically controlled oscillator. So we can connect that up to Raspberry Pi and make a sine wave generator that'll generate sine waves from basically DC to 7 gigahertz, any frequency you want, at plus 8 dBm. And the phase noise looks pretty good. We're working on this to try and make it a little bit better. It's like super flat out to about 4 gig, and then it kind of rolls off a little bit. We think we can actually fix this with some software calibration. And the, you know, the spectral purity is pretty good. I think we're tweaking the PLL and the oscillator a little bit to try and narrow that up at the high frequency. And wideband spectral purity is where this device really shines, because you can look at the second and third harmonics, and they're super low compared to even a lot of lab equipment that you would see. And again, this is run from Raspberry Pi and powered from Raspberry Pi, so you can control this over Ethernet, control it over Wi-Fi, and put it in your lab and use this to excite your radio or to look at other things in your system. And the big thing is, because it's actually an NCO, the DAC is running all the time. When you want to turn something on, it's just on and off. The step changes, response to frequencies is incredibly fast. And because we talked about like dog fooding, we try to use a lot of these things internally. When we test these things, we actually have calibrated Plutos that we use to actually do mass production testing of this to keep our test costs low. So we verify things with very expensive bench equipment, but that's not used in production test. And so we do these kinds of things. We release the test procedures, all of our things up on GitHub as well, so that you can look to see how that we do things and maybe replicate it in the equipment that you end up doing as well. And you can definitely come to our website, visit there, or come later this afternoon and chat with us at the booth. So I'll pass things over to Alexander now. Thanks very much.
Cool. So my name is Alexander Chemeris. I'm a CTO founder of Fairwaves. I completely missed all the time slots for CFP, so no funny stories, just bare facts at this talk, because we don't have much time. So who have heard about our XTRX? Raise your hands. Okay, cool, thanks. Well, you should hear about it more, because it's the best SDR, obviously. But this talk is not about XTRX, it's about 2 of our new products. It's XCOM, it's embedded platform for SDRs which we developed. And it's XSync. It's basically a low-cost massive MIMO SDR. So for those who do not know what XTRX is, just a very quick overview. It's mini PCI Express, embedded 2x2 MIMO, very high speed, etc., etc. But again, this is not the focus of this talk. So if you've watched my talks for the past few years, this is the questions I always ask. Have you ever tried to deploy SDRs in the field? Because that's a completely different experience from running anything on your bench. And so that's what we've been doing all along for many years. We design base stations based on SDRs, and we build platforms for this. So because we do base stations, we need high computing power, so we use Intel processors. And I've put together this comparison between ARM and Intel. Both platforms has pros and cons. What is important here is that from our experience, it's actually quite difficult to build an embedded platform. ARM is really good at embedded platforms. It's coming from embedded. Everything comes naturally. x86 is not. But if you really need x86 performance, that's what you should do. So that's why we've built XCOM. So first of all, our own pain was that we wanted flexibility in CPU. We have GSM base stations. They need very little computing power, but should be extremely power efficient. We want to run LTE. This requires Core i7. Plus, how do we survive end of life? Because equipment should live a long time. So the answer is use COM Express modules. Very standard, many suppliers. Again, anything from Atoms to i7s, maybe Xeons as well, will come on board. So this is XCOM. Very compact. That's critical for us. And it is designed for SDRs in many sense. So first of all, our Xtrix has 2 PCI lanes. So if you use a standard SBC that you cannot achieve the full bandwidth possible with this SDR. So we have 2 PCIe lanes, which allows us to get the full performance. Plus, it has control for power amplifiers, software controllable, high power DC-DC to control the output voltage, ADCs to measure VSVRs, which is important when you deploy something in the field. You need to know whether your antennas are connected or they're broken or whatever happens with them. So you could connect mini PCI Express SDRs, you could connect USB 3 SDRs, you could connect gigabit SDRs. So quite a bit of flexibility. And it is just a good embedded platform. Because as I said, it's surprisingly difficult. So if you want to have an x86 flying or floating somewhere or just standing somewhere 1,000 kilometers from you, where you have no control over it immediately, it's difficult. My most, the story which I like the most is ATX standard for x86 power, designed for desktop computers, and with ATX power supply, you can put your computer into a state where it's powered on, but it's not working. It's like the CPU is halted, right? Which is not a good situation when it is not near you. You cannot reset it. So it is surprisingly to get around this, how to make sure that if the power is on, the system is actually always on. And a lot of other things, small, like wide range power supplies, so you could run from solar panels, core boot support for safe remote upgrades, like Mark was telling about this yesterday at Keynote. That's very difficult. And that's pretty much it. So you can go to this link and see more details. So, and this is a very quick one because it's super simple. If you ever wanted to work with massive MIMOs, you probably didn't. In many cases, you didn't have money to buy it. So now you have. So that was a part of our original crowdfunding campaign for XTRX. And we found that many people really like this platform because it is low cost. Yes, it has some limitations compared to more expensive platforms, but for the cost of the platform, it does make complete sense. And could go up to 16 to 16, and even 32 by 32 if you combine 2 of them. And that's all I have for today. Again, sorry, no funny stories, no time. Thanks. Who's next?
So my name is Zach Lefke. I'm a research associate at Virginia Tech. I work for the Ted and Karen Hume Center for National Security and Technology. For those folks who know Bob McGuire, he was my master's advisor and then hired me on as research faculty after that. He is our chief scientist at the Hume Center, although he is retiring, which is kind of sad. But Bob's awesome. So I'm going to quickly go through just some projects that we've done over the last about 5 or 6 years. At the Virginia Tech ground station, we heavily use GNU Radio in pretty much everything we do. And we've always wanted to give kind of a more in-depth presentation and talk about kind of the stuff we have going on. Never really brought it all together, so you're going to get the quick 5-minute version. I'll try to be super quick. I could talk about any one of these things for days. So I'll try to avoid that. So here's kind of where we started. It was just a pile of old defunct trees. For those folks that know Virginia Tech, the building is actually called the tracking station. It's from rain fade studies that were conducted in the kind of late 70s, early 80s. And then it turned into mostly power systems using it. So they said, yeah, sure, you can use that whole area that's kind of unusable. That's all for you guys. So here's more of the just kind of view of things. So this is kind of where we started back in about 2014. We also had students. I don't know if some of you guys squint at that face, you might recognize it. That's Seth Heitfield. He's one of the original, I call him brain trust students of the ground station. So he's been involved in pretty much every step of the process. So from that, we now get to kind of the overall systems that we have in place. Mostly everything we're doing is geared towards education. So a lot of it is amateur radio oriented, not really suited towards kind of funded sponsored programs, but multiple subsystems that do a bunch of different things, which I'll hit on some of the things we've done here in a bit. This is kind of what it looks like now. There's actually that VHF, UHF stack. There's a second one now, kind of further back behind it, that's tuned to the federal bands. That's for one of our CubeSat missions that's going on. We're operating down in the 401 spectrum, which is great because that's also where we're close enough and the antennas are tuned to the radio sondes that they launch twice a day, every day, out of the Blacksburg National Weather Service station. So when we're not doing satellite stuff, we can track radio sondes and work with them. We are expanding. We have a new research building. Hume Center's been fortunate enough that we've done pretty well over the last few years. So we now have a new research building in the CRC that's not ours, it's the Vice President of Research's, but we occupy about 80% of it. And they're giving us the roof. I'm super excited because it's the only other building in the CRC that has proper lightning protection. The other one is the National Weather Service. So they're giving us access to the roof. So we're getting a federal S-band antenna, 2.4 meter antenna. We're getting a telescope and some other stuff. And then at the same time, we wanted to put a bunch of dishes on the ground, and they said, no, you can't do that. But hey, there's these big dishes down the hill. For those folks that know CNS from Virginia Tech, that's kind of our service provider. So back in the day, this is how we would send out like remote classes. And they wanted to decommission these. We're a state-owned, it's Virginia Tech, we're owned by the state of Virginia. They wanted to decommission these and get rid of them, and that would have cost them a couple $1 million to do. And so instead, they spent a few $1,000s to repaint them and just make them look pretty. These antennas haven't been used in about maybe 20-ish years, and they're giving over control of that to the Hume Center. So at the end of the day, we're going to have 3 tracking stations, 2 operation centers, and it's going to be fun. So the quick things that we've been using GNU Radio for, this is an incomplete list. It's all using GNU Radio, though. We've launched E310s on 2 different sounding rocket flights. One of them was just a straight-up experiment. Will this thing work? Let's downlink some telemetry from an Arduino-style sensor package. It worked beautifully. The sounding rockets are much more violent than your kind of traditional SpaceX or orbital ATK or Northrop Grumman launches. The E310 survived 20 Gs at launch. That's incredibly violent. So the second year we did it again, but we added a second E310 with the idea of it being a payload radio. So instead of just sending data to the ground, we wanted to also send commands up, and we also wanted to do something SDR related. This is all undergraduate projects, by the way, these sounding rockets. So it's incredibly, I'm very proud of our undergrads that are building things that are surviving 20 Gs at launch. And so we added an ADS-B and an AIS receiver, again, all using GNU Radio to kind of demodulate and decode that and then pump it back down to the ground station. The really fun part about this is we actually did this from Blacksburg. So the sounding rocket went out of Wallops, transmitted all the way across the state of Virginia to our 3-meter dish for the S-band downlink, and then we use the 4.5-meter dish for an L-band uplink to send commands. Basically, we use the commands to change the behavior of the radio and switch from ADS-B to AIS and back and forth. Launch to splashdown is about 15 minutes, so it's about a year's worth of work for about 5 minutes of on time, on the air time, and it's incredibly kind of tense but really fun. We also did a project where we're looking at FM interferers to the FO29 amateur satellite. That was a lot of fun. If I have time, I'll show a screen grab of what's going on there. Basically using the kind of known state vector of the spacecraft and backing out the Doppler offsets to identify where some illegal transmissions are coming from that are not hams, that don't even know that they're transmitting in the ham bands, but they are actually illegally transmitting, and we can see that. I like that. I work at the Hume Center for National Security and Technology. I call that project like a SIGINT problem, no clearance required, right? So it's great because it's good to kind of introduce students to the kinds of things they have to think about before they actually have their clearances. The AO73 to FO29 crosslink project was a really fun one. We were the first at the same time as a ham to decode a packet from AO73 that was accidentally relayed via FO29. So that project, the students actually had to model the orbits of the spacecraft, predict when this event would occur, predict what the conditions of the event would be, and all of that culminated with a finale where we had the decoders running at our ground station. We actually used their predictions to track AO73 or track FO29, and the carrot for them was if we successfully decode one packet, because this combination had never been done before, you'll get a half-letter grade bump on your class project. And I'm happy to say it was successful. There were 2 students that were present during that event, and they got the letter grade bump. Another ham out in the amateur community also decoded that same event, which is great validation that this actually worked. We built some solar eclipse, some satellite downlink monitoring nodes for the 2017 solar eclipse. We were basically looking at scintillation effects. Could we detect a scintillation effect on MRSAT downlinks as the eclipse kind of moved across the US, so that was fun. A student actually got a master's degree out of that work. The Virginia CubeSat constellation is the first wholly owned CubeSat built by Virginia Tech. We built some payloads for AMSAT a couple years ago. One of them is the camera experiment on Fox 1D. But this was the first time we built our own kind of total satellite. Our own, right? I like the saying, we didn't mine the ore, right? We bought a bunch of parts from a bunch of different vendors, glued them all together, and put it in orbit. We're using GNU Radio for command and control of that. We also have convinced or encouraged UVA and ODU, which are the other 2 universities involved, to also use GNU Radio. So it's GNU Radio all around for the TT&C for that mission. And then a whole bunch of other experiments, doing a bunch of stuff. SIGMF is super cool. Really into it and excited to be using it a lot. That's, for us, important for things like the TLE matching from Doppler measurements. Keeping close track of the frequency offsets at a very specific timestamp is important. We're doing that for things, the goal of that one is all these satellites, one right after another. When Fox 1D deployed, it was, I think, 28 satellites out of the chute in 5 minutes. So they're very close to each other. So if you can take accurate Doppler measurements, can you sort out quicker, which satellite is which? Use channel simulators, use GNU Radio to build channel simulators, done a lot of high-altitude balloon missions. I mentioned the radiosondes. That one a lot of people are doing, especially in the kind of DIY community. We do have the opportunity, though, to actually fly a lot of payloads on these larger balloons that are, like the balloon itself is bigger than the room we're in, 100-pound payloads, that kind of thing. So we've done a few of those, again, where we've used GNU Radio and SIGMF for some of the experiments. Heavy RF machine learning, right? Everybody loves machine learning. So we're using all these different apertures that I've been talking about to collect a bunch of data for training and all of that. I am not a software guy. I really wish I were. Everybody in this room intimidates the hell out of me with all of your skill and knowledge. But I've actually started taking my first steps to write my own blocks. Kind of proud of them. They're very simple. You guys would laugh at them. But things like SARSAT is the COSPA SARSAT, search and rescue satellite, so decoders for that to be able to actually decode and back out what's going on with emergency beacons. GRVCC is just, here are all the helper blocks we needed for the Virginia CubeSat constellation. Danny Estevez, thank you very much for all of your hard work. We're using that for the VCC constellation. And I've stolen 1 or 2 blocks from you and tweaked them slightly, and they're now in that GRVCC repo. The RF front-end control stuff, that's how we control our front-end switching. That might be useful for folks. It basically emits, uses tags from the tag stream for the start and stop of burst transmissions so that you can quickly sequence a front-end and switch from transmit to receive mode. And what else? Yes, SIGMF, SATMF, and Metasat. So we are working on something. It's one of those things you have an idea and you think oh, this is great. I have a great idea. Nobody else has thought of this yet. And then we look at the GNU Radio roster and what is Metasat? Oh, man. Because we were working on something called SATMF, which is pretty much SIGMF, just the next layer up and specific to CubeSats. It was a way of tracking the metadata and the data associated with small sat missions. And so I'm actually super excited about Metasat. That's not a ding, because this is good stuff. Hopefully we can work in sync. That part grew out of the old AMSAT satellite telemetry protocol, which is how they used to move data around on the internet. It's morphed into different things. There's not a lot of good documentation out there for all this kind of stuff. So we wanted to come up with an idea that's a JSON format for tracking things like the ground station identifiers, lat long, altitude, call sign if you have one. Things like that, and pushing that data around. There's a lot of other stuff. Like I said, I could talk for hours and days, and sometimes I have talked for hours about different projects. At the end of the day, it's all about our students. The goal of the Hume Center is to create the next generation of national security leadership and folks that want to work in that community, and we do that by engaging them on projects, right? So everything from fun kind of senior design concepts, a semester-long undergrad research project where they want to go and how do I use Skyfield? I heard references to Skyfield. That's awesome, PyFM. It was the old one. Skyfield is the new one. It's way better. So how do we point at a deep space probe? Go figure it out, and let's use Skyfield to point an antenna at something that's not in LEO that current trackers don't already work with, or tracking software. From that all the way up to sponsored projects from governments, government sponsors, commercial sponsors, where we have deliverables and the students are there helping us get the job done and meet the deliverables. So it's all about them at the end of the day. These are some of the students that were assembling the 4.5 meter dish. The Hitchhiker's Guide to the Galaxy is the theme of the ground station because it's a wild and crazy and ridiculous journey, but a lot of fun. With that, that's all I've got.
Thank you.
Thank you.